Good evening. This is Gopareddy from CIC. Today in this session, I am going to explain about the following topics in the chapter Wave Optics. Let us have a look at the topics. They are interference, coherence, thin films, and Newton rings. First, let us see about interference. Interference. It is defined as superimposition of two waves with the following conditions. They are same frequency, traveling in same direction, phase difference remains constant with time. Or it have another definition. It is defined as the non-uniform distribution of energy due to superimposition of two waves is called interference. During interference, intensity is not distributed. Interference is of two types. They are constructive interference and destructive interference. First, let us see constructive interference. We know that intensity at different points will be different. The point at which intensity is maximum is called constructive interference. Let us have a look at the diagram. In the following diagram, we are observing constructive interference where two waves with same amplitude traveling in same direction superimpose each other, and then highly amplified wave is produced with high amplitude that is equal to 2a. So that's why it is called constructive interference as the amplitude is increases. Let us see other type of interference, that is destructive interference. The point at which intensity is minimum and at that point the interference is called destructive interference. Let us see the diagram. In these two waves are there which are in opposite phase with respect to time, and when they superimpose they destruct each other. So that's why it is called as destructive interference. That's all. It's about interference topic. Now let us have a look at our second topic, that is coherency. We know when two waves are difference with time, so they are said to be coherent waves or coherent sources. Interference has several applications in daily life. Now let us have a look at third topic, that is thin films, and observe the interference phenomena in thin films concept. Consider a transparent film of thickness T and refractive index greater than 1. It has two refractive index. One is at the top layer and one it is at the bottom layer. Let us observe the diagram. In this, PQ are the top layers and RS is the bottom layer. When an incident ray A is coming outside the from the environment, refracted ray is BD. The refracted ray BD again gets reflected on the bottom layer QS, sorry RS, and get reflected and comes out of the thin film from the top surface. Hence, we can observe from the diagram. From the diagram, we can say that path difference delta B equal to BD plus DE into mu2 minus BG into mu1. Now consider from the diagram two triangles. They are BHD and DHE. First, let us consider BHD. From triangle BHD, where R is the angle of refraction, cos R equal to DH by BD, that is adjacent side by hypotenuse, equal to T equal to thickness by BD. Hence, BD equal to T by cos R. Now consider it as equation A. Now from the diagram, consider triangle DHE. Again consider cos R equal to T by DE and tan R equal to EH by T thickness. Hence from the equation you can rewrite it as EH equal to, again let us come back to the diagram and now consider triangle BCE. From triangle BCE consider sin I equal to opposite side by hypotenuse equal to BC by BE. We know that B equal to BH plus HE, which on further simplification gives 2T sin I into tan R equal to BC. Now substitute all the results in the equation. Delta B equal to BD plus DE into mu2 minus BG into mu1. Now look at the following slide. After further simplification, we get BC equal to 2 mu T into sin square R by cos square R. We know that mu refractive index in a air medium equal to 1. Hence by substituting the value and further simplifying, we will get the value delta B equal to 2 mu T cos R. And hence resultant path difference delta lambda by 2 equal to 2 mu T cos R minus lambda by 2. We know that there are two cases. constructive interference equal to delta equal to n lambda. Now substitute the value of delta lambda by 2 in this following result, and hence on further simplification we will get delta v equal to 2n plus 1 by 2 into lambda. By substituting the and varying the n values, we will get the different result as following. Next, let us see destructive interference. Delta equal to 2n minus 1 into lambda by 2, and as same as constructive interference, by varying the n value, we will get different values of n lambda. Now let us just see about the fourth topic, that is Newton rings. First of all, let me explain about the experiment. It consists of plano-convex lens with its convex surface touching the glass plate G, as you can see in the diagram. Here, a air medium is present between the plano-convex lens and glass plate. The point of contact is formed between the plano-convex lens and glass plate in air medium, and S is the source of light, which sends monochromatic light. And the lens L1 makes the light produced by the source to travel in parallel direction, and beam splitter, which is in vertical and making 45 degrees angle with the path of the light, helps the light to reach the plano-convex lens. Here the plano-convex lens is transparent and allows the light to pass through it. And the point of contact between the plano-convex lens and glass plate is the point of contact where the interference takes place. And the phenomena of interference is determined by the path difference. Determination of path difference. Delta equal to 2 mu t cos r. But in Newton rings, delta equal to 2 mu t cos r plus lambda by 2. Hence in air medium, mu equal to 1 and r equal to 0. That is, substitute these values, we will get lambda equal to 2t plus lambda by 2. Now we will get see about how to find the thickness of the glass plate. Consider the nth ring from the Newton rings diagram. It will have radius 2r. Let us consider each radiatum as Rn. From the diagram, we can see horizontal diameter is AB and vertical diameter is CD. We know that horizontal diameter term OA into OB and vertical diameter will be rewritten as OC into OD. And now by value substitution, we will get Rn square equal to 2RT minus T square, where T square is neglected. Now let us see constructive interference in case of Newton rings. We know that delta equal to n lambda, and now by substituting the values of delta from the former equations and further simplification, we will get dn diameter equal to root over 4r lambda by 2 into 2n minus 1. Similarly, in case of destructive interference, we know that delta equal to 2n minus 1 into lambda by 2, and hence further simplification, finally we will get dn equal to root over 4r lambda into n minus 1, where we neglect n minus 1, and we will get dn equal to root over 4r lambda n. There are several applications. And radius of curvature of plano-convex lens, determination of wavelength in liquid medium, and finally determination of liquid refractive index. That's all from this session. Thank you.